So today we're going to talk about complex fractions, or at least we're going to get started with talking about complex fractions. And first of all, we need to define what complex fractions are. And I know that I haven't cited it exactly like your English teacher would want, but a few years ago we used a program in math called eMath Instruction, and the author of those notes is Kurt Weiler. So I am referring to how he defined it, which is complex fractions are defined as fractions that have other fractions within the numerators and denominators. So they're fractions that are within an overall big fraction. That's what a complex fraction is. And what we're going to try to practice with over the next couple days is simplifying complex fractions. And in order to simplify a complex fraction, we still need to multiply by that fancy form of 1. There's actually two ways to deal with complex fractions, and that's what I want to try to do today. Is I want to show you both methods. On problem number 1, we'll do the first way. Two ways to simplify a complex fraction. One is to add or subtract the numerator, which is the top of the fraction, add or subtract the denominator, and then divide. And that's what we've kind of been doing already. And then the other method I'll show you on too. I can read this up here, but it's not going to make sense until you actually see it. But finding the least common denominator and then using that least common denominator to simplify. So the first example here, again, what I want to do is I want to do the first method. And again, what we're going to do is the same thing that we were just doing. We're going to take x squared over 32 minus 2. And remember that that's 2 over 1. I'm going to subtract it. And in order to do that, what we need to do is we need to find the common denominator. And the common denominator between 32 and 1 is 32. So we've got x squared over 32 minus. Well, we put 32 into the denominator, so we also need to put 32 into the numerator. There's that fancy form of 1. 32 divided by 32. And if we look at this a little bit more closely here, when we combine now, we end up with x squared minus 2 times 32, which is 64, all divided by 32. What else can we do to that fraction? Ready? Difference between two squares. We can simplify x squared minus 64, and when we do, we're going to get x, 8 and 8, different signs, all divided by 32. Well, what we just did is we dealt with the top of that fraction. I do want to go back and point out the fact that x squared over 32 is a fraction within a big fraction. We just focused on the top of that. We now want to focus on the bottom of the big fraction and what Kurt Weiler calls the minor fractions. X over 16 minus 1/2 is the minor fraction, and the overall problem is the complex fraction. But we need to simplify x over 16 minus 1/2. And when we simplify x over 16 minus 1/2, once again, what we're trying to do is we're trying to find the common denominator. It's a little bit better because it has numbers in it. But what's the common denominator between 2 and 16? It's 16. Ask yourself, does 2 go into 16 evenly? And it does. So this first fraction stays x divided by 16 because we didn't put anything into the denominator. But you have to write it correctly here because we said the common denominator would be 16. But what did we do to go from 2 to 16? Well, we multiplied 1 by 8. And hopefully we already know that. 1/2 is the same as 8/16. So when we simplify the green fractions here, we get x minus 8 over 16. Well, finally, the way I organized it up here on the screen isn't the best, but what's going to happen now is we figured out what the top of the fraction simplifies to be. We figured out what the bottom of the fraction simplifies to be, and now we have to divide. And that's when I say, go old school. Take x minus 8 times x plus 8 over 32. Again, that was in the numerator, the top of the fraction. And we're going to divide it by what's in the bottom. Well, that was x minus 8 over 16. And by the way, the bottom of a fraction is called the denominator. And then to finish, when dividing, don't ask why. Flip the second one and multiply. So we still have x minus 8 times x plus 8 over 32. And then it's going to be multiplied by 16 over x minus 8. We flip the second one and multiply. So lastly, do we have anything exactly the same on the top and the bottom? Well, hopefully you see the x minus 8s. If we write this down one more time, what we now have is we have 16 times x plus 8 all divided by 32. Can we do anything else? And hopefully more than one are shaking their heads. What's 16 divided by 32? 1/2. So we can write it as 1 times x plus 8 over 2, or just x plus 8 divided by 2. And essentially, once again, that's what we've been doing. We've done a lot of practice this week, and that's what we've been doing. But I want to show you an alternative here. And the alternative, as I digress here for a second, we need to find the least common denominator of all the denominators in the problem. In fact, the minor fractions. And then we're going to use that to simplify our fraction. So here's the second problem. What we look at here is we look at 2/3. It's a fraction within the overall big fraction. 2 over x, another fraction within. 5/3 within. 5 over x within. Look at the denominator of each of those fractions. So 3, x, a 3, and an x. And the question is, what's the least common denominator? 3x. So what we do, once we find the least common denominator of 3x, is we take that least common denominator and we're going to multiply it by each fraction. We're going to multiply it by the 2/3. We're going to take the 3x and we're going to multiply it by 2 divided by x. We're going to take the 3x and we're going to multiply it by 5/3. And we're going to take the 3x and multiply it by 5 divided by x. So we multiply that. So something that I realized last year is that multiplying and dividing still cause people some trouble. You might have to write it over 1. But remember when we multiply the tops together, we multiply the bottoms together. If we're lucky, do we have anything exactly the same on the top and the bottom? Well, we have a 3 on the bottom and we have a 3 on the top. And when we cancel those two out, we're left with x times 2. And then 1 times 1. 3 divided by 3 is 1. Do we need to write the 1 on the bottom? No. So we go to the next term here. 3x times 2 over x. What happens is, do we have anything exactly the same on the top and the bottom? We have an x. And so what's left here is we're left with 3 times 2. And 3 times 2 is 6. Down here in the denominator, do we have anything exactly the same in the top and the bottom? Well, we have a 3 here and a 3 there. And we're left with x times 5. And finally, on this last fraction, do we have anything exactly the same on the top and the bottom? We have an x, and we're left with 3 times 5, which is 15. So now, what we need to do to finish. We've gotten rid of the fraction within the fraction. Can we factor the top of this? Yeah. We can factor out a 2 with GCF, and we're left with x plus 3. Can we factor the 5x plus 15? Yes. We factor out a 5, and we're left with x plus 3. And to finish, do we have anything exactly the same in the top and the bottom? And we're left with 2/5. End of part 1.